All right, number 40. Which graph best represents the solution set of 3x is less than 2y plus 6? Well, this kind of looks like lines, broken or solid. We have some lines. Well, we got x and y. That kind of makes me think of the linear equation, right? So and we solve that linear equation pretty much the same way that we solve an inequality. What we really have is an inequality. Okay, so let's just rewrite this as an inequality. All right. So we have 3x is less than 2y plus 6. All right. Well, let's get this y and then the inequality and then the rest. So let's subtract 2y, both sides. So negative 2y plus 3x is less than positive 6. Well, we don't really need that positive in there. It's just 6. Okay. Well, let's get the x on the right. Subtract 3x. Subtract 3x. So we have negative 2y is less than negative 3x plus 6. Okay, almost there. Almost there. Well, let's divide by negative 2 to get that y all by itself. We divide both sides by negative 2. Well, we divided by a negative 2, so now we have to switch the direction of the inequality. But that's okay. We'll just keep driving on. So we have 3 over 2x, because a negative divided by a negative becomes a positive. And then we have 6 divided by 2, which is a negative 3. All right. So first of all, we can graph this. I'm going to just write this cleanly over here. We could graph this. Now, the one thing I want to show you is when we have an equality, we use a solid line. So if we had an inequality that was equal to, it didn't matter, it doesn't matter whether it's greater than or less than, as long as it's greater than or equal to or less than or equal to. You're still going to get a solid line because it could be equal to. But if you have either a greater than or a less than symbol, you're going to use a broken line. And that's what we have here. And that's important because we can look at our graphs and immediately eliminate B and D. They cannot be right. Right, so then we have our slope of 3 over 2. And we have our y-intercept of negative 3. Okay, so I'll just write it cleanly up in the middle. Okay. Looking at our y-intercept, we can see that both of those check out. they have a y-intercept of -3. Right? Now, let's take a look at the slope. I'm saying the slope is 3/2. So let's get the line tool out here. Let's make it red. Let's make it broken. So rise of 3, run of 2. Rise of 3, run of 2. So that checks out. But we can't rush to judgment just yet. How about the other? Rise of 3, run of 2. Okay. So our slope didn't work. Well, the last thing that we're left with really is the shading. So our y values are going to be greater than our 3/2. And so I take a look at these two and I say, if I were on the y-axis and I need to be in the shaded area, which of A or C shows that I stay in the shaded area as I increase in the y-axis? Because I'm saying y is greater than. So it could be any number that's bigger than when we put an x in here, what this computes out to be. So if I put a 5 in, let's say I put a 2 in here. 3/2 times 2 will give us a number 3. When we subtract 3, it gives us a 0. Is 0 not in this shaded area? It is in the shaded area. But over here, the 0 on the y-axis is not in the shaded area. So what I'm going to do is choose C, because I think C represents what the statement is saying. All right, let's check our work. C is correct. There you have it.